Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Under strongly acidic conditions, conc. H2SO4, tertiary or benzylic alcohols undergo dehydration via carbocation intermediates. The key here is an intramolecular Friedel-Crafts type alkylation, acid-catalyzed cyclization. Step 1. Identify the starting material. The starting material is a compound where a cyclohexane ring carbon is connected to a carbon bearing to phenyl groups and one OH group. Looking more carefully, the structure shows a cyclohexane ring at the top whose bottom carbon is attached to C-pH, 2O. This is effectively 1,1-diphenyl, 1-cyclohex, 1-vial, methanol, but the ring attachment suggests the OH-bearing carbon is directly bonded to the ring carbon, making it a tertiary benzylic alcohol. Step 2. Protonation and carbocation formation, conc. H2SO4 protonates the OH, giving water as a leaving group. This generates a tertiary carbocation at the carbon bearing to phenyl groups, C+, pH, 2 attached to the cyclohexane ring. Step 3. Intramolecular cyclization. The carbocation is stabilized by the adjacent phenyl groups. One of the phenyl groups can undergo intramolecular electrophilic aromatic substitution, Friedel-Crafts cyclization. The carbocation acts as the electrophile attacking the ortho position of one of the phenyl rings, forming a new C bond and creating a 5-membered ring fused between the two phenyl groups and the central carbon. Step 4. Rearomatization. Loss of a proton from the intermediate arenium, valent, ion restores aromaticity. Step 5. Product identification. The cyclization forms a fluorine-type skeleton. Since the starting cyclohexane ring is involved, and after ring contraction or direct cyclization of the diphenyl carbocation, the product is 9,9-diphenylfluorine, a fluorine, dibenzofuran-like bicyclic system with a 5-membered central ring bearing both phenyl groups on the sp3 carbon, C9. This matches option B. Why other options fail? Option A places the two pH groups on different carbons of the 5-membered ring 1,3 positions, which would require a different mechanism and is not the product of simple intramolecular Friedel-Crafts on a gemdiphenyl carbocation. Option C shows a methyl group, but no methyl group is present in the starting material. Option D is eliminated because option B is correct. Therefore, the correct answer is B. Therefore, the correct answer is option B.